Have we finished the lecture last week? Have we finished all the whole PowerPoint last week? I don't remember. It's fine. Powertrain.
Yes, we finished.
We finished that. Yeah. Okay, then we do. Now we focus on this one. So today we just doing a kind of the revision to go through what we have done for last few weeks about the lecture. Yeah. So this is my topic is called From History to the Future. You see how the EV development for the whole arrangement, whole thing like. So because in coming Thursday will be the midterm is carry about 20% of the grade is also quite important. Yeah. So bear in mind all my exam paper will more focus on the PowerPoint and the homework. Have you all submit your homework?
Yes.
Okay. Have you able to see the answer? And my answer should automatically be released after last night, right? Have you? You check if able
I
to see?
didn't check the homework.
Okay, you can check it now to see if you are able to see the module number 6, week number 6. You are able to see that. You can check it to let me know. While you're checking it, so today we're going to examine about the EV history again, about the EV development and the powertrain and the propulsion system. Review again, and then talk about some power electronic and the future for the EV. Now, we have been studying for quite some time now. So today it asks you, what's the meaning of e-mobility? The topic of the course is called e-mobility. So that to say you should able to now know what meaning of mobility. So what do you think? What's the e-mobility?
E-mobility, I think not includes electrical vehicles, but also the electrical vessels, boats, and also electric with some both with electrical machine.
Okay, you can see that all the moving parts we can consider them as electric mobility. So that's why they are quite important. So the history, we all know briefly about the history of EV anyway. They're also quite important nowadays. And from the history, we know that EV has been developed nearly 200 years, maybe at least 150 years, until today we got really nice EV. We got the full self-driving EV nowadays, self-driving, and also, do you know about the major EV part? What's the major EV part? What part is now available for EV?
Motor, battery, and control unit.
Yeah, that's a major things. And then for the motor drive, we also have very important drive technology. So technology drive, we got 4 motor, 4 wheel, and we also have how we connect them. We got 2-wheel drive, 4-wheel drive, even though we got using differential system. And then for the propulsion system, then we can also looking into what kind of propulsion we have. Usually for the old day, we only have ICE, but nowadays we got the motor, we use motor to power all the propulsion system. So the EV motor can be used for EV, but of course in the past, we are also talking about other type of the motion. But basically all the EV motor are powered up by the new energy fuel, like the hydrogen fuel or battery, maybe the ammonia, what we're talking about here. So for the powertrain, then the powertrain means all the key power component in the train. For the battery up to the wheel, that's our powertrain. So that's the basic thing we have learned in the past. So in here, then we know that the content we're going to discuss today, including the e-mobility again, how the EV environment has been changed for that 1 century. And then the concept for the EV motor, and also motor drive system, and the powertrain, and also the EV power electronic. Why power electronic getting so important for EV nowadays? And then we conduct a few case studies to see anything important. Firstly, again, let's look at what's the meaning for e-mobility. So basically, you can see that I think we all try to relate them to electric vehicle. So electric powered vehicle for transportation, we call it e-mobility. And basically, we try to reduce the reliance from the fossil fuel, and we try to lower all the greenhouse effect. That's a key important message. We want to go for the e-mobility. So you see mobility, this term, not only used for ground vehicle, can also including the vessel, aircraft, and also for space transport. So that means even though spaceships, space shuttle, space traveling device can also be e-mobility. Aircraft, all different type of aircraft are also part of the e-mobility. So the key driver for the e-mobility must due to all the environment. Today we have global warming. We don't like to see that. We have a lot of emission, roadside emission. We also don't like to see that. So gradually we move on to have a more environmental friendly system. We want to reduce all the air pollution. So that's to say, we also have a really good advancement in power electronic and battery. Before, the electric vehicle can only run for maybe 30 miles, but now will be at least 300 miles. I think we can able to do much better. You see, for the last 100 years, 100 years ago, we run for 30 miles. But after 100 years, we only run for 300 miles. That's not enough. We need to do a bit more. So we need more advancement in battery and also power electronics to push that further. I think more importantly will be the government policy. Without government policy, you can't do anything. If the government do not support EV, no way to go in any country. That will be also important. So government need to put some policy, make sure that we can all change to EV. We also have a timetable, like last time we said, each country have their own timetable to do that. And also incentive. Government need to initially have some incentive. That means 10 years ago, we all have some incentive. When you buy an EV, government, you will have some subsidy or maybe tax allowance so that people will like to buy an EV. You see, initial development for EV is really expensive. An EV usually about 2 or 3 times more expensive than gasoline car for the same kind of the performance. So that means without government support, government incentive, during that time it's impossible. But today is quite different. You can see today when we in the new vehicle registration, I think at least half of them will be electric. So that means the people have already feel comfortable to use EV. So the benefit for e-mobility, of course, is due to we don't like the emission from the exhaust pipe. Exhaust pipe consists of not the CO2 or other pollutant, NOx, which we really don't like. We pollute our health, pollute our respiration system. So because of carbon footprint issue, required by whole industry, everybody talk about the carbon footprint. So we want to use electric means, and we can therefore reduce carbon footprint. The thing is, when we use electric vehicle, the electricity don't have to come from power generator, can come from wind power or solar power. So that could be 100% zero emission. And also the cost. Electricity at the moment, energy cost would be cheaper than the gasoline. If you want to use an electric vehicle, the operating cost usually about only 1/3 as compared to gasoline vehicle. So that means if you use your vehicle really often, have a long mileage per trip, then you better to use electric because it's much cheaper and save a lot of money. I guess maybe in near future, when we impose the carbon tax, any emission that will heavy tax due to carbon tax, then that will be even worse. So that means to use electric will be a better choice. Maintenance. We know that EV, we have less maintenance. If you open up EV, you don't see too many components, only a major component, like the motor drive, battery, controller, that's it. We don't have any other component. So that's why EV today, we are saying that you can review a lot of the parts, less moving part, less motor, less component has come through all the gasoline vehicle, ICE vehicle. And more importantly will be efficiency. EV are more effective. The efficiency of the EV from the energy source, from battery, the motor will be at least 95%. And then for the gasoline, only 15 to 25. So we can't compare anything. And also that about the power regeneration, this one has power regen. Gasoline has no such things. So obviously, we have to use the e-mobility for all the transportation system. And then the key component for EV, just recap what we have learned, will be this lecture mainly to recap what we have learned. So including the battery system, then you can see that basically store the electrical energy. We are using lithium-ion battery. The key metric to look into the battery system will be the energy density. What kind of energy will be needed? That means the kilowatt hour per unit kilogram or per unit volume. And the charging time, can we use 1C, 2C to charge? Even though you use a supercharger, if your battery is not good enough, you can't use your supercharger. And lifespan, how many years, how many cycles you can use. That's also important component you need to look into. And the motor. So it basically converts electrical energy to mechanical energy. So that is to say, we can able to control the motor to control how the energy being transferred from electrical to mechanical. Then we can use it to provide the torque and make sure the torque can be smooth. High torque, we can use it to switch the motor. Maybe when we overtake the vehicle, we can therefore use instant torque to control the vehicle to overtake or to speed up. So that's a motor will important. Torque control will be important component for vehicle control system. Power electronic, of course, my field will be on power electronic. Why we're on EV? Because power electronic and EV are really highly related to each other. You can find a lot of the system in electric vehicle are mainly based on power electronic. So that's why we work on this area. Another thing will be about the inverter. I say inverter, what's inverter? It basically convert the DC into AC to drive the motor. So all the motor are more highly related to AC waveform. So although some motor we call it DC, but you can see that the waveform we try to drive even the DC motor still are AC waveform. So that's why basically we have to use inverter to convert DC to AC to drive the motor. But for vehicle, we still see a lot of DC converter. Like the charger is DC converter, and also some of the motor, like DC motor, we are using a DC converting system to vary the voltage. So that means power electronic relate to motor control and charger, DC bus, they're all important components. For the structure, I mean, these are all 1, 2, 3 are all vehicle components. But number 4 is mainly about the infrastructure. You see, at EV, we need to look into the infrastructure, mainly because EV is not a single vehicle. Nowadays, the EV are connected together. So that's why we have something called a connected vehicle. The vehicle being connected to each other. Human beings cannot connect to each other. We can have phone, but EV, they connect internally. They got the control system, connect them internally. I cannot control you. We only can communicate with you. But EV are connected. So much more advanced than communication. So we have so the charging system, we're able to use charger to communicate with each other. And when we have V2G, we can able to do communication. And basically, before we have communication, we do have the AC charging system. An AC charger usually will be for something called the standard charging system or for slow charging. Or even though some of the medium charger, we use the AC charging. Another one will be the DC charging. Usually you refer to fast charger. So for example, like some rapid charger or supercharger, we are talking about will be the DC fast charger. And then for a different type of the vehicle, basically we have really basic one, the battery electric vehicle. I think in the first time when we use the electric vehicle, many people will specify it to be the battery electric vehicle because they say the energy power from the battery. So they say battery vehicle. Then of course, all the vehicles today, most of them, 90% of them are battery vehicle, like the Tesla Model 3, Model Y, BYD, and Nissan Leaf. And then hybrid, also one of the important area. Hybrid is mainly, it means we are using the battery electricity together with ICE, combine them together. We get both type of the power output. So that means some like the Toyota Prius, Honda Accord, they're hybrid. That means they do have an electric motor together with ICE. They can use both of them to power the vehicle to run, or you can use ICE to charge up the battery. So that's why we call the hybrid. So hybrid do have advantage because we don't really need to rely on electricity. Because at the moment when we don't have sufficient charger, we may more rely on hybrid because we got more gas station. We can see a lot of gas station. We did not see many of the charger. And charger we need 1 hour, half hour, or maybe more time to charge. But gasoline vehicle, we only need about 3 minutes. So that makes the big difference. So that's why hybrid vehicle has been dominating the market, especially when Toyota Prius have the hybrid, they can really make people like electric vehicles. But since Toyota Prius have this that, then we gradually think if we got a power source, why don't I charge the battery? So that's why Toyota Prius convert the vehicle into plug-in hybrid. So that means they also have a charging connection to the battery system. So you can either inject with the gas or inject with the cable to charge it. But what's the main difference between these two batteries? What do you think? For these two vehicles, what is the difference between the battery between these two? What do you think?
The plug-in hybrid would have a larger battery.
Yes. You see, simple hybrid like this one, the battery, you don't really need to charge up all the time, only half charge, so that you can allow time for you to decelerate, braking the engines feedback into the battery. So that means the engine here only charge half it. And then for the plug-in hybrid, because sometimes they want to use plug-in to charge, the battery needs to be larger so they can get more energy. So usually they can double the size, maybe 3 times. But still, this kind of battery is only very small, maybe some of them from 2 kWh up to 5 kWh. And then plug-in maybe go up to 10 to 20. And they can really comfortably to using plug-in to charge or to use gasoline to charge. So for example, like many of them have a plug-in capability. Some vehicles they may all mainly electric, but they also can give you a version of the plug-in. And I need to double check with BMW i3. I think i3 only pure electric. I think i5 or i6. You can give me a hand to check. BMW, which one is the plug-in hybrid? Basically, BMW i3 is only pure electric. So I need to double check that. But anyway, then another one with fuel cell vehicle. Today we got a lot of fuel cell vehicle in the market now. And like in here, Toyota Mirrors. Mirrors is one of the popular one, Hyundai Nexo, also one of the really good brand. You can see that they are more likely to be developed by the Asia region. The like Toyota Prius have been launched about 4 years ago. It's really popular, but still, we don't see that many hydrogen stations yet. So that means using hydrogen fuel still are challenged because we don't have that kind of the good facility for a large range of hydrogen stations. As I mentioned many times, hydrogen we need to have pressurize them to 700 bar. So in a way, it may not be too convenient for the user. And the next thing will be the battery technology. So for e-mobility, we think the battery technology will really limit the performance for EV. including the energy density and the range. Yeah. So that means, of course, we all prefer to have battery have a large energy density, high energy density, so that the weight can become less, the size can become less. But that may not be the case. And then another issue will be competition from the ICE vehicle. To refuel ICE, we only need short period of time. But then for battery, we have difficulty to run for long distance. So that means the battery technology is still something hinder the real development for electric vehicle. And the infrastructure at the moment, the thing is, the infrastructure for the EV still are not really healthy at the moment. We tend to extend the infrastructure so they can cover a larger range of operation. At the moment, our infrastructure for EV only cover a really small area. So we have difficulty to enlarge so that everywhere we got charging station. You see, gas station is now sufficient. But nowadays we got more and more electric vehicle. Then if our own garage is not sufficient to charge, we need to go outside and charge. But you can see the supercharger or high power charger is not there enough. In the market, for instance, in here, Tesla have their own charging system. The price are different from those European standard. So that means the charger outside, they may use another standard, not the Tesla. Like on the campus, I'm not quite sure. On the campus, do we have any Tesla charger? No, they're all European standard, right? So if you want to use Tesla, you need to use another adapter to change the European standard into Tesla standard. So that means we may have difficulty to charge here. Yeah, that's why I know many of our colleagues are using Tesla, but I'm not quite sure we have any Tesla charger system. But anyway, you let me know to see anything. But so if the charging have different connection, so that means we need to have a wide range, widespread of the charging stations to do the job. So that means that relate to the standard. Different charger, different standard. I think I mentioned to you last week. Tesla have their own standard, right? And then you also Japanese car have the charter mode standard, European standard, IEC standard, and also in China standard, GM, GB standard. They all are quite different. And that's why it makes the infrastructure become more complicated, because if you want to build a charger infrastructure, which part you want to use? And these are four major standards being used here. If you only put the Tesla, then how about other vehicles? But having said that, today for the new vehicle registration, there will be more Tesla than other vehicles. So there's something not quite sure to do that properly. And then EV have another issue about the upfront payment. If you want to buy any EV, then the initial costs are much higher. I think last week we also mentioned about initial cost. So that's something we need to be careful. Initial cost. You're going to have high initial cost, but end up to be you need to pay back slowly because your electricity cost will be lower. Number 4 will be the grid capacity. Once we look into EV, we will have high demand for the electricity. Everybody going to charge it. Then you may not have sufficient electricity to cover it. Then a normal vehicle, even though Tesla vehicle talking about 40 kilo of charging system. So you really need a high power charger. So that not all the household able to support that high power. So there's something uncertain. We are not quite sure about that. Of course, we also need to looking into the battery advancement. So we know that in coming year, so-called the solid-state battery will be coming out. Do you know why we like to use solid-state battery? What's the key advantage of solid-state battery compared to conventional battery?
Because in solid state, we don't use liquid.
Sorry, say again?
We don't use liquid.
Yes, that's right. Yeah. All the battery, like lithium, we have to liquid base of the electrolyte. Although not that liquid, gel type, but still a liquid base. But solid state means solid state, really solid state. So that's good. So that means the high current punch through will be much better. The thing is, if you look at battery, you got a positive terminal, negative terminal. In between them, you got a separator. In between them, the ion can go through the separator. They have a really little hole here. However, this hole is so small, only allow the ion to pass through. If you're using lithium ion, for example, they can pass through. And then between here will be the electrolyte, the electric or gel type. Of course, they're really thin, close to each other. So you can see that because the liquid form, then that means they are much easier to have damage. If the liquid form is not evenly distributed, then the distance between them will be closer. The separator and this one will be closer. The separator just makes sure these two will not have short circuit. You see, if the electrolyte is not linearly distributed, in case these two are close to each other, something like that, close to each other, then this will become short circuit. The separator is insulator, but however, separator, if they use for some time, they will get this, some occasion will get thinner. They're not really evenly thickness. So if there's a little bigger hole here, they will cause a short circuit. You get explosion. You see, this kind of short circuit is internal short circuit. You cannot protect externally. Even though here you have a fuse, you can't protect any internal short circuit. It's still circuit internally. So that's why this is really important for the battery design. But for solid state, we don't have that problem. It's because they're solid. They evenly distribute across here. So that's why it becomes safer. So that's why we like solid state. And gradually improving the energy density will be getting higher and higher. You're able to perform higher fast charging. When you have high power charging, this will get very hot. Hot, then you need to separate only very thin kind of the plastic to separate them. And then this thing will really scare about high temperature. In case of high temperature, this will get aging. They have very small hole here. When they get older, if you use a microscope to look at it carefully, they got many little holes here. When you under high temperature or low temperature thermocycling, this hole may sometimes may get bigger and bigger or smaller, and then sometimes you got some wrinkle in here. Then you see what happened here will be they may not able to separate properly. They may not able to isolate two polarity properly. Then in case they touch, short circuit. And this will get aging quite easily. So that's the thing we need to look into. And solid state, we don't have that problem because they're solid. And then about recycling. Battery, we don't quite like battery because of the recycling. We cannot have any battery. Can easy for it to recycle. At the end of life, probably we go to the landfill, which we don't quite like that. We're going to create a lot of rubbish. Like in our city, all the rubbish is dumped into a landfill. So that creates a big problem. Even though, and you have a lot of plastic, so even their battery packaging, internal separator, they're all plastic, or the battery subsystem, they're all plastic. All the plastic sometimes go to a landfill. Sometimes by mistake, we go to the ocean. There's a lot of accumulation of the plastic in the ocean now. I think if you look into the, so that's the United States. I don't know how to draw. That's California. And then there's a dump site for the plastic right in here. On the very close to California on the east side. Because of the water circulation on the earth. So it seems there's all the plastic around the earth, including America, they will start to circle, accumulate here, become a really big collection of plastic. I don't remember the name. If you look at some website, will be like that. Then it's just the whole ocean full of plastic accumulated in certain area because the water current, they try to spin and locate in there. So it's become a big plastic yarn. So there's a really disaster. I mean, there's a few locations on the earth because of water movement on the earth surface. They accumulate all the rubbish plastic. So that's really disaster. If your ship go nearby you, then you will see that's a really major disaster for the planet Earth. But anyway.
The Great Pacific Garbage Patch.
Oh yeah, Pacific Garbage Patch. Yeah, so that's a really big disaster. So anyway, so that's why we need to review all the battery recycling issues anyway. And of course, next thing will be the autonomous vehicle. You see, autonomous vehicle is so important nowadays. All the new vehicles, they do have a program implemented inside to become the autonomous control. Sometimes we call it full self-driving or full self-driving, FSD. FSD. Oh, full self-driving. So that means, of course, look like you don't need to do anything. They can just do it by themselves. So, because of this one, people will enjoy it really much because when you have a full self-driving, that will give you the protection because usually the car accidents are due to the human error. So we can also give you more relaxed when you're driving your vehicle. The third will be the wireless charging. Today we all use conventional method to charge. So in this case, half time we need to plug and unplug are really inconvenient. You see the charger plug, they need to handle high current, tens of amp, maybe 100 amp. So this kind of the connection have power losses. And so you also the aging. So when you have wireless charging, now your phone, you can just put your phone on certain location, you can just start the charging. That should be really convenient. So that's why we prefer to do that. So that's why wireless charging will be getting more important nowadays. I think for the new model for vehicle, we are thinking about to install all the wireless charging, like what we did for the phone system. Then because so many chargers, you need to look into the vehicle to grid. One vehicle plug in to the power grid or power distribution. Then they're connected. So the information from vehicle can transmit through the power grid to other locations. Not only for energy. Basically, we have energy transfer. So that is to say, the energy from the battery, we can use it to power up the grid or vice versa. So we can stabilize the grid in case in the day you don't have sufficient energy. The battery from the vehicle can power up your building. Or in case of power interrupt, your battery can support. Because nowadays the EV battery is quite large energy content. Tesla, say Model Y, probably will be 80 kWh. 80 kWh, your household usually about 30 kilowatt. So you can able to for a household for 3 hours. That would be nice, right? So that is to say, EV to grid with something we are already working on for many years. We also working on the EV, the V2G in terms of the communication, some information being transferred through the grid system. And then, of course, we have the hydrogen vehicle. Today, hydrogen are getting more important. We tend to use hydrogen to power up many things. And so in this case, we need to think about how are we going to manage with hydrogen safety, hydrogen operation, how to get the supply chain for the hydrogen. So they are all supporting important how we build many hydrogen charging stations. So that's the item we also need to do that. But today we just go through our revision before the midterm. So we go through from really beginning from history to the future of the vehicle. So here you have seen that in the past, but I want to go through that, make sure you understand for about half of the class, half of the duration of the class, I go through some quick revision so that you know what we have been doing. So next session about the rise of the EV in the early 20th century. I think the history of the application usage of EV has been fluctuating for the last 200 years. I think I also mentioned to you 100 years ago, the EV was very popular. 1/3 of vehicles on the ground are using EV, but it died down for due to the performance being much, the ICE performed much better than EV during the time. So the rise of EV in early 20th century, So would be give us a really promising performance in the time. The maneuver, the control, everything is good. But anyway, the performance is less comparable to gasoline car. So that's why it become not that popular. But EV has been welcomed by many people. Key thing is the noise. You don't have the amount of noise as compared to combustion engine. So I think combustion engine, they has been spent a lot of the investment to reduce the combustion engine noise. They put a lot of the noise and compressor to reduce the noise engine. So again, gasoline car, there's a lot of there's a low cranking requirement. So that's why EV are much easier to operate. And also there's a low exhaust. You don't need to worry about the exhaust system. So for urban application, then that's really nice to use it. For technology, then you're able to put a lot of the smart capability for the vehicle, make the vehicle easier to be smart. But for gasoline car, the control is not so convenient. We can't do 100% smart vehicle. Because carbon neutrality, then gradually we accept the requirement for the carbon zero, carbon neutrality. So we need to gradually move on to the zero emission vehicle. But you see, in the old day, we have the battery based on lead acid. I think everybody knows lead acid. Basically, your start vehicle, your 12-volt battery in your car using lead acid. Even though the electric vehicle, 100% lithium ion, we still have a battery there, 12-volt battery, for the computer control a basic electrical mean. So that little battery are separate from the key for main battery system. So that little battery usually lead acid, but of course can be lithium. So, however, if you in the early days when you only use lead acid battery, you can only run for short distance. 900 years ago, all the electric vehicle only run for 30 miles. At most 50 miles if they're really big and heavy. So that's why charging during that time will be really slow. We don't have fast charger, we don't have fast battery. You see all the lead acid battery, the standard charging speed, we call it 0.2, only 5 hours to fully charge. Battery, lead acid battery is not good for 1 hour charging. It damages the battery. The best charging will be only using 20% of the current. So that's no good for the lesson. You can't use it for the fast charging. You need to wait for 5 hours every time after you finish using it. That's why lifespan is low and just 1 year, usually 1 year, you need to change it. At most 2 years if you don't use the vehicle that often. So for the performance, then the top speed only 20 to 30 during the time. The typical speed only about 10 to 15 minutes slow. During time, the motor is not that capable, really is quite slow. So that means the vehicle during the time only for short distance, urban city traveling. So the design are mainly for small vehicle, light vehicle, and only for a little bit of carriage. And also during the time, many women like to use it because it's easy to operate, only go and stop. Yeah. And so that's why many of the ladies like to use the electric vehicle during that time. So the market share during that time, you can see that in the 1990s, EV account for 1/3 of vehicle on the road in the US. So it's quite a good number. We need to remember that. So major city like Chicago, New York, have a lot of the electric taxi during the time. That taxi are really similar to London taxi, if you know the shape. That's really popular. And for the manufacturing during that time, is Detroit, Baker, Columbia Electric, they all produce various type of the EV. You see, like the Detroit, they produce 13,000 vehicles in that time. So that's why you can see it's very popular. And also the famous user like Thomas Edison also own Detroit Electric. So it's quite surprising. Edison had one. Other popular people like Caraflow, Henry Ford are also using the EV. I mean, it's really popular. Many of the celebrities are using EV during the time. Must be really popular. So earlier EV you can see that the range is quite limited, as you said here, not suitable for long distance because we don't have good battery. After a distance, they need to recharge it. So that's why they usually are not suitable for the outskirts, only used for the city. Charging station during the time are really rare. We don't have sufficient charging station. Although it's DC charging during the time, but still not sufficient. So however, later on, gasoline vehicle become getting popular. One thing is they have developed the electric starter. You see, ICV, when we want to start a vehicle, we get a starter. In that time, how do we start the ICE? ICE, we need to have some people using a very thick cable, pull it to start the rotation. So that means in the initial, when you use ICE, you're very inconvenient to start the vehicle. Although we know ICE using gasoline, you can run for 100 miles, 200 miles. But if a young lady, during that time, 100 years ago, you want to start your ICE, you get your servant maybe to pull your rock to start the vehicle. So inconvenient. But however, in 1912, they developed an electric starter, just a motor, like what we're doing. You just have to start the ICE. So press a button, then it start. The people like to use it. So that's why you make the operation of gasoline become popular. And then gradually, once they got the starter, they start to invest more in the ICE, become more high power and high performance, less consumption of and less emission. And so Henry Ford, Henry Ford is the Ford manufacturer, very popular. They developed T model. And then since then become getting popular for the automotive market. And more importantly, and then they discover really cheap oil. In Texas, they have discovered a really large oil storage. So since then, the oil gasoline become really cheap. So that's why it makes everything become popular. I see. So once ICE becomes so popular, then of course electric car is not able to compete with the gasoline vehicle. So and then after that, then EV become gradually diminished from the market. By 1920, gasoline vehicle actually dominated the whole market, mainly because long range and also low cost, cheaper oil, really cheap oil. The infrastructure, mainly gas station, everywhere. So if you drive gasoline vehicle, you can really easy to fill up your vehicle. And the mass production by Henry Ford can make that become more affordable. So much cheaper than electric vehicle. So that's why gradually we can see the EV disappears. So after that, from 1930, then EV started to disappear from the market. So very few EV have been used, but still some of them are used for delivery or some special application, but getting less and less during that time. So you can see the trend for development. Originally, EV dominated the market, and the ICE become better performance. The ICE dominant our market. But today, we are the other way around. EV start to dominate our market. So ICE start to become dominant. Since then, we can see that a lot of the development, including all the key inventors, they invent different type of the gasoline vehicle. Key thing, you can see that many manufacturers, just like what we have done 15 years ago, many manufacturers start to develop the electric vehicle. But during that time, 1990, many manufacturers start to develop the gasoline car. And then the key thing is gasoline car during that time will be much more mileage, 100%, 100 miles, 200 miles. But electric vehicle only 30 miles, 50 miles at most. And fueling, we all know that a few minutes to fuel the vehicle. Mass production, the technology will be well developed during the time by Henry Ford. So become mass production means cheaper, affordable. So again, you can see that starter is the key thing. efficiency is key thing make the vehicle become popular, and also the infrastructure. We got many gas stations. So all these things will make a vehicle become popular during that time. And for economic thing, low cost for the gas, for the gasoline, because the Texas, we got a big manufacturing there, and also mass production. So that make it all become popular. You can see the price. I think Ford vehicle in time had 850 initially, 850. But of course, 150, 120 for 850 is not the money. You can buy a house. And then after, later on, it become 925, the price go up. But however, due to the mass production, you return back to 850 after 7 years. And then the price will gradually drop to 260. After a few more years after about 15 years, the price dropped by 50 to 260. You can see that the price dropping not so much, like the EV vehicle. I think the Tesla, in the first time when you buy a Tesla, it could be about 100,000, but now only about 30 to 40,000 you can get one. Much cheaper now. They got a good manufacturing, low cost battery, you make it become cheaper. So all the product are using similar trend. Mass production can make the thing cheaper. So that's why the EV during that time, we talk about history. EV during the time are declining due to the gasoline are dominant the performance, dominant the market. So mainly key thing is the infrastructure, energy, supply, the cost, make it become less demanding. So you can see that ICE now become a really successful transportation system. But today, you're also getting a challenge. So you can see that the early EV, 120 years ago, EV give us a really early groundwork for modern EV mobility. The basic principle, like the battery and also motor, are the key two major elements for electric vehicle. But in the future, because the people like the EV, because they are thinking about all these things can be reversed. Like the infrastructure, we can build more charging stations. And also EV battery system, we now have a good battery technology. We also have renewable energy system. We can make the EV become zero emission. So the lesson we learn from the past can be a kind of the teaching material for us today, how we improve the EV system. So that means, so that it gives you the basic thing about the history. So next thing we like to give the revision to you about the motor. I think last few weeks we discussed about the motor, then you know briefly about what the motor are. So the major motor we can see here, 1, 2, 3, 4, 5. Firstly, the DC motor. DC motor, of course, the most basic DC motor. Besides the switch reluctance, DC motor is also one of the early development of the motor. So basically, you have a PM permanent magnet and also a winding, or sometimes the PM can be replaced by the coil with generate magnetic flux. Another one will be the permanent magnet brushless DC motor. We don't like the carbon brush and commutator. We can replace them by the power electronic to switch the phase angle to switch the polarity. So I think we learned last time. The third one was industrial motor. Industrial motor basically is an AC motor. We need the AC three phase to drive them. We can power a motor electrically without power electronics. You can only using the three phase like this, directly connect the motor, then you can rotate. And it's really mature technology, more than 150 years. You can see that in the beginning when we have the electric vehicle, it's driven by DC motor. Gradually, when we are AC, then we move on to AC motor. Their time for development are very close to each other. And the next will be switch reluctance motor. I promote this one because high fault tolerance, really safe. And also they got a high-speed version. We're able to run at several tens of thousands RPM. And third one, the fifth one, the permanent magnet synchronous motor. Permanent magnet synchronous motor is very similar to this motor, but this one usually reverted to using AC waveform to join. AC waveform, you can still, they change polarity every half a cycle, and then the permanent magnet will be facing their polarity, synchronize them to rotate. So this using DC switching, this one using AC to have the force interaction. So basically, we have these 5 major motors to use in the market. So the first area will be, we need to understand to do research and technology for the motor control, how to control all the motors, and how to examine about the power regeneration. Power regen will be important so they can save more energy, and how to improve the energy efficiency. So we have been working on competitive type of the EV and also their motor system. So for all 5 of them, they got different advantage against each other. You can go for my original notes. You can see what they are. So basically, you can see this table to show you all the different kinds of the motor system, basic motor, DC motor, induction motor, SR motor, PMSN, permanent, synchronous motor, and so many of them. So we also have different software to design control them. We also have different power electronic chopper, controller, converter to convert the power, and also hardware, which microprocessor and ESP, VCU to do that, and also some kind of the software control method. This goal is that is give you all the whole things, whole picture for the motor system. So we also talk about a few motor. Let's do some quick revision before. So this lecture, we try to go through what we have learned. Make sure you can do remember them. So all the things covered here may appear in the midterm anyway.
How many questions will be?
It's not how many questions. I don't remember how many questions, but about 2 hours. So the exam next coming first day, you start day 1:30. You have 2 hours to do that. And then we have MC, multiple choices, and also have some short questions. You may, I don't remember if you need to do some sketch or drawing. If you do require you to do some sketch or drawing, then you can use whatever software and in your computer to sketch.
Then can you draw and then take picture and
you can use in your cam to sketch it on the paper, take a picture, upload back into the canvas for the submission. Whatever you do, right? Yeah. Or in the submit, sometimes canvas are quite stupid. If you want to upload a file, they may not able to do that. If it really is that case, if you ask this question, ask you to upload file, the canvas does not allow it, you can email to me. Just in case. If I'm not here on Thursday, in case anything happen, I can't do anything. So in case anything happen, then you upload by yourself using your own email method. Okay. You or even those put it in paper, put it under my door. They'll also be okay.
we need to come here for the midterm.
Yeah, you can, please. Yeah. And I prefer to come here than because the regular location is quiet here, nobody disturb you. In theory, we can do it anywhere, but I think since we have class here, then you know each other, then in case anything, your computer is working or whatever, you can get some support. Of course, in the exam, you're not allowed to talk to each other, but it's open book, open notes, open everything. Then you can do your own management. In case first day, the computer is not working, my camera is not working, it really have happened, then so be it. Then we need to cancel it. Yeah, but I don't think that will be the case. Anything, seldom you can give me a call, and then I see anything happen in the computer system in cameras that cannot be come up. Usually it should be quite okay. So in here, go back to here. The PM motor is one of the important motor we like to discuss. Because the thing is, we like to use brushless. Without the brush, then we can able to review all the current spike, voltage spike, and the lifetime for the commutator, common brush can last for longer. But for PM, one of the major disadvantages for PM will be the magnetic thrust are fixed. So if you want to control the motor in overdrive, then we cannot use the method called the field weakening. Because PM is a fixed magnet, we cannot weaken the field. But we know that for overdrive property, we do need to weaken the field. So that's one of the disadvantages. And so some people, they even put a small coil there. In case you want to weaken the field, you want to use the small coil to interact with the magnet to decrease the field, opposite the field. So some people will like to do that. So this motor is good because when we use PM, the field are strong. We don't need to use a coil. In this case, we can use it to design very high performance, high torque motor. So actually the power density of this kind of motor are smaller than industrial motor. But industrial motor, we still like it, mainly because it's popular, low cost, really mature, has been in the market for more than 100 years. So all the technique, how to do this, how to manufacture, how to repair are well known. So that's, and also because AC type of motor, we don't need any commutator. AC automatically can reverse the polarity. So we don't need to worry about the contact and polarity. And the material control method are, as I mentioned before, we use constant VF control. The voltage and current, voltage and frequency are proportional to each other. When we want to decrease the voltage, we want to decrease the frequency. Why we decrease the frequency? We want to change the RPM, the speed. You know, RPM, rotation per minute. We call RPM. I think you must know that. Yeah, RPM. Rotation per minute. For RPM. We just call it how many RPM that you know is the rotation speed. The key advantage for industrial motor, because robot. Why robust is important? Because sometimes with overdrive, a little bit overspeed, overcurrent, over voltage, when they're quite robust, it won't easy to get damage. But of course, the winding, something you need to be careful will be they conventionally to use copper winding. This kind of copper winding may have problems because due to the high frequency. The thing is, before when we AC, we can try a motor, the AC waveform. But nowadays we tend to use so-called the VSD or inverter. Then this waveform sine wave, this waveform can become pulse width moderate. This kind of switching waveform. We use that switching waveform to make it look like sine wave. So that means this high frequency is therefore impacted to the motor winding. Between the wire, they have high frequency. High frequency means they have leakage. They cause AC losses. So that's why they don't quite like that. So that's why whenever you use this kind of the inverter, you may create more high frequency losses.
Is it recording?
Which one?
This lecture?
This lecture? This lecture is a quick revision, what we have learned for the last 6 weeks before the midterm.
Is it recording?
Regarding the midterm?
Record.
I'm sorry?
I mean, are you recording this one also or not? Like recording?
We record. I'm recording all what you.
This
what
one,
we
this
have
lecture,
learned.
because just to give us
Some revision.
some.
Because after a few weeks, then I want to give a revision to all of you so that you can get the critical point, important point for my teaching. Here, I just go through, already we teach you about industrial motor. I just pick up a few important points to remind you which portion, which part will be important. Okay, so we call everything.
So this lecture is also recording, right?
Yeah, yeah.
Thank you.
Yeah. Oh, you mean recording? You mean
Yes.
audio recording?
Yeah.
Oh,
I think,
okay. Yeah, we record here. Later on, we may, sometimes I record it, but if not working, then cannot display it. But this lecture is already recorded. So, but anyway, so in here, then you can see that this one is very mature technology, so well developed. Once anything is well developed, much lower cost, so much more convenient for user. All the technology, all the method to control are well known. And the commutator already well decided, then we don't need to use any commutator at all. So-called the low commutator, because we use AC to do the switching. And control method, we are using VF control, field on control, and direct control method. VF control, as I mentioned last week, the voltage and frequency are changed simultaneously. So when we reduce the frequency, we will reduce the voltage. For this motor is really robust because this motor is only with the silicon iron and copper wire winding without any PM. The whole structure and design are straightforward and simple. So that's why this motor can be used for small power, 1 kilowatt, or high power, even a megawatt. We can also find many of the industrial motors. But this motor, high efficiency, but just slightly less than the PM motor because it don't use PM. The efficiency used 1% to 2% less than the PM motor. Another important motor called the switch reluctance. The switch reluctance motor is really popular because due to the safety. Each of the phases are highly independent from each other. So in case anything happens, this kind of motor can able to still continue to rotate without stopping because each of phase are different from other. In case one phase broken, you only lose out a portion of the torque. So the control method are slightly more complicated because they use a special arrangement of the transistor. And we also need the position control for the precise position sensor. So that means the motor itself have one region of motoring, one region of regeneration. So we need to control each region properly by using the transistor turn on, turn off angle, turn off and turn off time. So the key advantage will be highly reliable and low cost and high power density. But disadvantage will be still the ripple will be large. Mainly because from pole to pole, second pole to second pole, there won't be any control. In this case, the ripple can be large. And then the 4-quadrant control, you also need to learn about it. You learn briefly about 4-quadrant control. Basically, first quadrant means forward. When you want to control motor forward, you call it forward. Then in this case, the torque and speed are all moving in the same direction. And then the third quadrant control means reverse. Reverse the torque, reverse the speed. So that's why I go to the 180 to 270 degree region. And the motor itself also, third quadrant means we're going forward, but we also like to perform the power regen. Then it becomes the second quadrant, the fourth quadrant, also power regen, but it's in reverse manner. You see, power regen is important feature for EV. We make use of this in order to reduce the speed. And then simultaneously, the energy can be returned back to the original battery. And then we can also examine about the downhill, we can return the energy. So that's all the important feature. So I think for the future, we need to look in a number of areas, including how we're going to design a future motor. The future motor must be highly effective, high performance, and also good cooling. A motor high power is mainly related to efficiency, power losses. If you can able to remove the heat, then the motor will perform better. You see the winding resistance. So we got some coil here. This winding are highly related to frequency. The AC resistance will give high losses. Once high temperature, resistance will getting higher. So the loss will getting higher. So that's why you have a kind of the effect. High temperature means even high loss and higher. So the good thing to make the motor to perform well is to reduce its temperature. Even high temperature, we have a really nice, really good force cooling to remove the heat. That's the thing we can do. But I think in the future, we're looking into what? Looking into some new material, so we're able to reduce further about the losses. We also examine how we improve the speed, high speed. That means we are able to use smaller motor. We only need to use a gearbox to convert it. And then we also need to put some intelligence. some kind of AI or machine learning intelligence, we can use it to optimize the motor control method. Today, when we control motor, not only control the torque and the speed, we also need to control the coordination for different motor. We have 4 motors in the vehicle. We need to coordinate them properly so they can perform the best for torque and speed. In here, the wireless charging is also important. I think we are seeing that many researchers are looking into wireless power transfer, wireless charging. So this must be a really good topic because we can transfer power without cable. In this case, we don't need to worry too much about the cable connection, joining, and safety. The next thing will be about the powertrain, how we're able to have a good powertrain to power up everything. Like what we mentioned before, powertrain include from the input to the battery and also to the motor. So that including transmission, vehicle control unit, battery system, and also a lot of powertronic related to them. So mainly the powertrain component, including all this here, motor, battery system, powertronic charger, transmission, and the transmission mainly looking into the drivetrain. If I ask you what's the drivetrain, that include the motor and also the wheel, and perhaps it's the gearbox if there's any. So mainly about how to drive the vehicle. And vehicle control unit, VCU, mainly just more like the vehicle computer to control the whole operations. So here we try to compare the ICE to the EV. I think you all can develop this table. Power source, one is the power source for ICE is the internal combustion engine, the other one would be the motor. And then for the one is gasoline or diesel, the other one would be electricity. Efficiency will be this kind of different by many times, at least 4 times of the comparison. Emission, one is low emission. An electric vehicle have low emission, 0 emission. Then we also learn briefly about the power conversion. Power conversion, we learn from the input to battery will be AC to DC power converter, mainly called the rectifier. And then we also have battery DC into the AC, that will DC to AC conversion. And then we have the battery to other control electronic, that is DC to DC converter. Battery can be 500 volt. The other control electronic can be 12 volt. So with this kind of the variation. So the voltage changes can have many different kind of the arrangement. Here we show you a few examples. For instance, for low power vehicle, and the golf car will be 48 volt. So for 8 volt, and then for high power vehicle, we got this range 150 to 500. And then we also have large vehicle like buses, usually 800 volt. This kind of the high power range. High voltage, usually for high power because we can decrease the current. Of course, thermal management also really important. We also need to control the vehicles, make sure that the temperature will be less than something. The best temperature operation will be room temperature. So because for all the vehicle, all the components, they try to design room temperature because that's the normal temperature range they try to operate. So, and even though sometimes they may not good for 0 degree, for instance, battery is not really good for 0 degree. So room temperature even better. The control strategy for thermal management usually using the coolant to cool down, or sometimes we'll be using the air cooling, which using a fans to do that. So the design objective, we also mentioned about it. For powertrain design, 6 areas we need to look into how to optimize the design objective. One is the energy efficiency. How we're able to perform the energy performance, minimize the losses. For train operation, we also need to examine about how to balance the energy capacity and the weight. That to say we can use a lot of the battery, then the vehicle can run for a long distance. But however, we also need to look into the weight. Once we put too many battery, too heavy, then the vehicles have poor efficiency. And the acceleration, how quick the vehicle can speed up. As I give it homework 0 to 100 km per hour. Then we also need to looking into how we can speed up the acceleration. what kind of motor will be needed. Power regen, we've been concentrating on motor drive, but we should also focus on power generation. When we are going down the hill, how we can design a motor so they can have more energy to return back to the battery. So, of course, the vehicle weight, how to good material to reduce the vehicle weight. And at the moment, the EV price is more competitive than ICE now. ICE, I think you can get 20,000 or 27,000, 30,000, you can get SUV. But for the vehicle, actually, they're all pricing at around 30,000 to 40,000. But after some tax, they may become 50,000. But you can see that 30,000, 50,000, you can buy a quite good EV already. ICE, sometimes 20,000 to 30 something thousand, you can buy a good ICE. So the price between them is not that much different. Before it was about 3 times different, but now will be really reasonable. We also talk about different kind of converter. So we have talked about giving some lecture on buck converter, boost converter, and buck boost converter. So last week, you also have really good understanding for different converter. You know how to select the converter, how the duty ratio related to output voltage. So you have to know about this. So this kind of the DC converter mainly is to work on the power supply or so-called power converter and voltage regulation. How to control voltage. For instance, from 300 volt reduce to 12 volt, how to control as constant 12 volt. Then the three-base converter only for freeway. We practically use other more applicable converter, like in here, 2 transistor forward. Using 2 transistors, we're able to regulate the voltage at medium power. 3 to 4 kilowatt, we can use this kind. And then next will be full bridge, can be for any power level, because they meant to be work at high power. So in this case, this full bridge forward converter, I think also show you in the looks, you're able to operate at least 2 kilowatt, really flexible to control output voltage. So you see the future development for all this, that will be highly related to this field area, battery, motor, how many motor will be configured. Before we only use 1 motor, but nowadays we talk about we can use 3 motor, 4 motor, and depend on all your arrangement. Hydrogen vehicle will be coming, so that can be a good challenge or another competitor as compared to electric vehicle. All the vehicles are integrated with AI, so AI was something we need to work on the vehicle so that the AI can able to help us with the autonomous driving, more intelligent put into the vehicle. So, finally, you can see that final remark will be, we can say that what we learned here will be, we learn about the powertrain, which are using battery, charger, converter, motor, and drive. That's the key component. If some people ask you what is a powertrain, you can know what component will be needed. So we need power conversion, change the voltage, change the current. So in this case, that will be also power converter to a better management. The thing is, the vehicle battery will be 400 volt. We can't use 400 volt to drive your computer to high voltage. You must reduce the voltage. To reduce the voltage, basically we need to change that. Going to be DC, we cannot change the voltage. Directly, we have to use power electronic method. So the DC voltage, we first need to use an inverter to raise that to a high frequency. When we're using a high frequency, then we can able to use smaller transformer to reduce the voltage. So basically, you can see that we are using transformer plus a converter to do the job. So now then we come to the why we need to use power electronic. We've been talking about power electronics for quite some time. But basically, the power electronic is to convert and control the electrical power in the EV. It can also provide better energy transfer efficiency. So that including how we design the future battery, how we design the controller, how we design the motor driver to make it more highly effective. So the component may including in here how we generate important control method. We also develop the battery charging system. For a motor, we need to design how to control speed and torque and also angle of the direction of the motion. We also many converter in the vehicle, we go DC to DC, DC to AC, AC to DC. These three are major converter in a vehicle. Which one to use? Depend on what kind of voltage you're trying to use. You see some vehicle, they may also using high frequency AC to control them. So anything that can happen. So section 5 is trying to talk about the key component in EV power electronics. I think you all studied the EV for quite some time now. So firstly, we must have the inverter. Inverter is a DC to AC system. You can enable the speed control. Then DC-DC converter is to control DC voltage, like 400 volt control to 90 volt, or 300 volt we control to 48 volt for different voltage. Then all the vehicle has the onboard charger. Usually onboard charger are AC. Because onboard charger, we have to plug into the AC power point. Onboard charger seldom have DC. I don't know onboard charger DC. Why is that? Mine do not see any onboard charger in EV are DC charger. All of them are AC charger. Why is that?
One thing is DC charger can reduce the current stress on the kit. This is the first thing. And the second thing is the mainly charger for EV is a high power grid. The AC is more useful for the high power. DC will be more expensive.
Mainly DC charger are directly to use DC to power the battery. Battery itself is DC. AC charger means we rectify it first, become DC, and then we connect to the battery. And then onboard charger, which is more suitable for home user. For home user, we don't have any DC at home. All our power source at home are AC, like all those 108 volt. Even though outside in our parking lot, we have some charger, but they all developed by our university. They all are AC charger. So AC charger, that means they use is trying to support you medium to low power. They don't give you too much energy because they don't want to invest too much. So you can see there are AC charger. They are not really a charger. They only give you a wiring connection. From you see the AC charger at your home or maybe in your parking lot. It's just AC in here, and your EV is here. Then you say the AC charger or something like that, and then you plug in to your vehicle. But that is not a charger. This is only a cable connection, or maybe a meter to measure how much energy being used. Only a wire. From here to this still 108 volt connection. So that's don't call this charger. It's only a connector. The charger is inside here. Okay, so that's charger. So this is called the onboard charger. Onboard charger. And then of course your vehicle also have this and then battery here. Then we also have a DC charger. That's really a charger now. The DC charger AC, they pass through a rectifier, become DC, and DC connect to a battery, directly connect to the battery. The DC charger, the control mechanism are inside the charger. They control the charging profile, CC mode, CV mode to charge your battery, directly connect it to your battery. But in this one, they only give you a wiring. So that means don't mix up AC charger and DC charger. The name we use in the public are not really right. So that's why we got an onboard charger, which there's a small charger inside the vehicle to convert your AC into the battery voltage. And then all the vehicle inside we have a BMS, battery management system. A battery management system, as I asked you, can a BMS have function of charging? One of the multiple questions in the midterm exam will be, what's the function for BMS? charging? Would that be a function for BMS? BMS is only battery management system, not battery charging system.
Yeah.
The charger is here. The battery BMS integrate work together with battery. They provide you with the protection, measurement. That's it. They don't charge. So that's the difference between BMS and charger. And then vehicle, we also have a lot of the DC-DC converter level with the three basic converter here, but some other converter like forward converter, H-bridge converter, they're more popular. We are using H-bridge converter most of the time. And then you also have the inverter to convert DC into AC to power up from the battery to the motor. All the motor, no matter AC, DC, the waveform are really much look like AC anyway. So we still can use the inverter. Of course, only certain type of DC motor, single phase DC motor are using DC-DC converter. Most of waveform like the switch reluctance motor, brushless DC motor, induction motor, synchronous AC, they all are AC waveform. So AC and DC, that means the charger, we convert AC 100 volt into the DC to connect to the battery. So this one, the charger, you can see that from AC input connection, they are AC to DC converter. And the EV motor control, we're looking into the control of the motor. We have the speed control, torque control, directional control, control the angle movement. We also need to control the power regeneration. All four of them will be basic control requirement for EV anyway. Although they're really basic, you all know that. Let's just list out what the basic requirement. Then why I always mention about power electronics, because my key research area is power electronics. We use electronics to control all the appliance, all the converter, all the power unit we mentioned just now. They all are power electronic system. So we can use them to control the efficiency, how to perform from AC to DC, how the performance look like, how the efficiency look like. We're also looking into overall performance, how to control the motor torque. The motor itself, we only control its voltage and also frequency. We have to use all these two parameters to control the motor torque and also the speed. So that's why it's a kind of special control method. We only use voltage and frequency, control the motor frequency and torque. We also need to control the power regeneration, how we can have better way to return the energy to the battery. So that's also quite special. So power electronic, not only this one, we also need to mention about the power, the energy losses. Whenever we conduct electricity in the power device, power will be lost. So we need to look into the power electronic, how to provide power electronic, how to make them become really highly reliable. And reliability is important, especially for EV. When you drive an EV in the highway, if suddenly one motor is broken, then we are not quite sure still safe or not. Although it's still safe because for good control system, they can balance the wheel, but not all the vehicle. So that's why reliability is important. We don't like to, in the middle of the highway at midnight, suddenly the battery say, oh, you display 20%. Actually, it's 0%. It can be when BMS is not working well. The display for the state of charge may be not the correct answer. Then when we really go down to 0%, but the display only say 20%, you end up with a disaster. So that's why reliability will be important. Next thing will be integration. You see today the vehicle look very tidy and neat, mainly because they use modular approach. Each module consists of some major component, integrate them together, become a really good-looking, highly safety, highly reliable package. For instance, motor and motor drive can package in a single unit. A charger, including onboard charger and also other energy management, they can integrate into same thing. And the battery, they integrate with the BMS. So just a few components there. So that's why now all the control are much more tidy. But in the future, we tend to improve further. So that means, I'm not quite sure you heard about for power electronics, we will have something called a silicon carbide or gallium nitride. They are all two major transistors nowadays to use this technology to improve the operation frequency and also power loss. So now they we're able to use silicon carbide and gallium nitride to work at more than megahertz easily. Before still can, but now become much better. Well, at high frequency means the switching speed turn on, turn off time for the transistor become higher. So before the transistor maybe turn on, you're talking about say in here 0.1 microsecond. But now they can using that speed, right? Here will be maybe 0.05 to 0.01 millisecond, much faster. So that means you see last time we mentioned about the zero crossing, overlapping, on-off overlapping, we got power losses. So for instance, we have this kind of losses. For example, right, we have turn on and turn off. Then the power losses will be inside this so-called overlapping. And the current and voltage are overlapping, more overlapping time, you got more losses. If the transistor switching at very high speed, then this duration will be instead 0.1 millisecond become 0.01. Then the losses can be reduced by 10 times. And other thing we need to use will be the integration we mentioned. We also mentioned about the wireless power transfer, right? The charging. We also mentioned about AI control. Nowadays, all the components have their own intelligence. Like AI control, vehicle, self-driving, they're all AI technology. Some components, they have their own local intelligence. So they perform their local control rather than use central control to do that. That can reduce the time spent in the control configuration. So now then, finally, we have some case study to look into what we're trying to say. So you can see that one case will be in the Norway. Why Norway have a really high adoption of EV? So the key thing is so successful in Norway. You can see that 2021, they got 30% of vehicle sales are already electric, much earlier than many other countries. Many other countries only 2025 are 50%, but they already have 50% of all the vehicle sales. And really significant reduction of CO2. Key thing is the government have no tax, no tolls, and free parking for electric vehicles. They got a lot of the charger all over the city. And also lot the education to educate the public to use electric vehicles. So there's some case study why this country, Norway, can do the job really well. Next thing will be in China. I mean, it's also another successful case. And the key thing is because the government has a lot of the incentive, policy, investment in the charger, make sure that everybody can charge the vehicle. And also they got a number of good manufacturers, like BYD, MRO, it's a major manufacturer. They a lot of investment in the EV manufacturing. And market growth will be also quite important. So they have a lot of the EV sales and also the market quite large. Our promotion, the infrastructure mainly will be a large level for a charger. So if you go to a few major cities, all the taxi, all the buses are all electric. So that's how the successful case. So for Japan, why the Japan a failure case? You can see that Japan is one of the early vehicle manufacturers to work on a hybrid, but they did not focus too much on electric. They try to focus on hydrogen. That can be some of the disadvantage. During that time, they may think hydrogen is the winner, but turns out to be not the case. They developed on hydrogen for many years, but still the market share still nobody like to use hydrogen. They don't like the transition from hybrid, which is hydrogen vehicle, or total previous transit into fully electric. They don't like that. They still stay on hybrid vehicle or stay on hydrogen vehicle. The infrastructure for them is not good enough. They don't have sufficient charger in the market. They only try to put on a lot of the hydrogen charging system. But in other countries, like the US or China, we have a lot of the competition. We have so many manufacturing in EV and also in the charging level. And the market as well, two major players like Tesla and BYD are two major players in EV, but that is much bigger than any manufacturer in Japan. So that means Japan is lagging behind in EV by nearly 20 years. So really difficult for them to catch up. So before 40 years ago, EV auto market is really strong. One of the big, I think, govern the whole country, 1/3 of the income, but not anymore. So that makes the country become worse. So that's an unsuccessful case in EV development in Japan. They think EV is something good, but the EV is not driven by battery, EV driven by hydrogen or hybrid. That becomes failure case. You can see the market, how many hydrogen vehicles, how many hybrid vehicles, then you can know why they become fail. So that's the case study I'd like to show you. So final remark before the midterm. Today we just show you overall view for everything, what we have learned for the last 6 weeks. So in here you know that mobility, I think, is the future. It offers so many good, so many advantages as compared to gasoline car. And then the key message I'd like to show you will be EV using a really good motor. All the motor performance are more than 90%, 95% efficiency. That's the key performance. High torque, high performance, high standstill torque. Long lifetime, low maintenance. That's why we like it, right? And also the electronic provide a really good feature to control motor to any kind of the operation. And the power electronic are good because it's efficiency. A good design power converter should have 99% efficiency. Of course, we can't have 99, but 95 is quite common. If you go out to buy a power converter, usually they're more than 95% efficiency. And then for EV history, you can see that EV has been there for many years, more than 100 years. It has been really famous, but now it's famous again. So in the future, EV or e-mobility will be a really good topic because a lot of the technology there. I think mechanical people will need to switch to electric because many work are there. And so the government need to do more work, like in the industry, consumer need to start to switch to e-mobility. And more research will be needed, like autonomous vehicle. At the moment, the best will be level 4 to 5, but now we go for more level 6 and 7. And then we need to look for more robotic control, including the robot, EV, e-office are merged together. In the next few more years, we're looking into V2X, vehicle to everything. So that's it. So I think my last statement here will be evolution of EV over the last 20 years significantly transformed the concept of mobility. So it changed so much. Now our mobility is so much different from 100 years ago, right? So that's it. Any other question? So next Thursday, come here, then use your canvas, your course to do it. I think our course starts from 1:30 for 2 hours. In case you cannot finish, you just carry on to do it, yeah, until you finish. I only deduct a little mark if you submit late, but don't be too late. If everybody submit on,
I need your favor because I will be in South Carolina.
At 1:30, you still put on your computer to do your work between 2 hours and press the submit button. I think I set the time limit for 2 hours. Once you open, let me see.
1 hour 50 minutes.
1 hour.
50 minutes.
Oh, because we finish the class at 3:20,
Yeah.
not 2 hours. So you start, yeah, I think you see the time right there. So we finish at 3:30, 3:20. So if you're outside the city, then you watch the time, try to finish 3:30. After that, the marker will be there to show your age. Then the system may integrate. Yeah, okay. Can you do that at 1:30?
No, I cannot. I will be having presentation there in the conference.
Okay.
I cannot.
then your case will be specially matched.
So should
But
I
you still-
email you? Should I email you separately or what?
No, because the canvas is on online and submission. It's not paper submission. It's not email data file. You do everything at the multiple choices and the question are filled in the band, everything on the canvas. So you just do it on the software, the tech call. The tech call is equals to the canvas, right? I think you already.
Yeah.
Just do that. I think you should start May and finish May and also be okay.
Okay.
I know your case.
Thank you.
Okay, that's all. I need to go now. I need to take the flight. I'm not fine to Hong Kong.